Hey, everybody. My name is Carlos Mariscal. I am an assistant professor at the University of Nevada, Reno. I've been involved in SOCIA since the beginning, and I'm here to talk to you about universality in and of evolution. So I'm going to start off with some motivating questions. Then I'm going to tell you why you should care. I'm going to give away my view, and then I'm going to give you a roadmap so that I can go into it in a little bit more detail. And then I'll wrap up doing it again. So my motivating question is, can we know anything about life elsewhere? And if you know anything about the previous work that I've done, whether it's on convergent evolution, origins of life, extremophiles, universal biology, you know that my answer is yes. A related question that's a little bit more conceptual, it's taking a step back, is the question about what the source of that knowledge is. And one way of phrasing this is what we know about life elsewhere due to what we know about physics? And I'm going to say no. Essentially, this is going to be my view. There's going to be alternative views that I'll discuss, but I'm going to say that evolutionary theory, properly understood, and in most respects, does not depend on facts or features about laws of physics and of this universe. That might seem controversial now, and it hopefully won't when I finish. But then you'll have to, when I finish, you'll maybe rethink what you meant by physics. And then you will have possibly a rejoinder that, oh, no, you actually do mean physics, just a different kind of physics. I'm like, okay, well, fine, sure. So this will make more sense in a couple of slides. First, I want to tell you my ultimate motivation for this. I have just been interested in having a deeper conceptual understanding of biology since we started, since I was a second semester graduate student, really. I think that knowing the source of our explanations, the ultimate justification for our views, is interesting and important, just for feeling comfortable in the generalizations that we make in biology and the claims that we make in the life sciences. One reason why this is the case is that when we justify scientific practice, when we ask for explanations, we typically don't look for explanations that are the default. Let's give you an example. You don't need to explain why I'm not floating away right now. I'm on Earth, and Earth's gravitational pull is bringing me down. That is a default explanation. So the question, why am I not floating away right now, is not the thing that you should ask. If I did start floating away, then because it is a violation of the default explanation, that's when you start taking a special explanation. And I think the same thing could be applied to the life sciences. If there are general explanations that are expected of life and there's violations, those raise questions. But if science doesn't know what those are, then we might spend more time trying to explain things that don't need to be explained, such as why diversity or complexity increase in evolutionary time, that kind of thing. Why species don't become best adapted. And then lastly, I don't think physics has had its house in order since the turn of the last century. We don't have a grand unified theory. We've discovered dark matter and dark energy. And it may turn out that the best explanation for dark energy is that our laws of physics are incorrect. If that's the case, some people would say, well, we might need to rethink all of biology. I don't think we would have to rethink all of biology. I think there'd be quite a bit of biology that would withstand a revolution or two in physics. So that's the preface. It's the first 5 minutes. I'm telling you what I'm going to tell you. Then I'm going to tell you that. Then I'm going to tell you that I told you that. It's what I tell my students when they write papers. I don't like surprises. So I'm going to give you a brief overview now. I'm just going to talk about entities and history as the correct understanding of evolution. And I don't mean correct as in this is the one and only view of evolutionary theory. It's just that this is a central aspect that's relevant to this case. Then I'm going to tell you why previous philosophers that have wrestled with these issues have gotten everything so very wrong. And then I'm going to give you ways to challenge what I'm saying. So I'm a philosopher of biology by training, and no philosophy of biology talk is complete without quoting Richard Lewontin's 1970 piece, in which he makes this three-part recipe for evolution by natural selection. The beauty of this is that it's actually fairly generalizable. And if you wanted to, if you were going to be a pedant like I'm about to be, you could structure it as an argument. You don't need a living system, but you can have a system in which parts interact with things that are not their parts, right? Namely the environment. And there are variations in the parts or the members that can enter the system. So here, organisms can be different, species can be different, variation. There's heritability or inheritance or some sort of retention across time of variations with a positive probability. I've thought about what it would be like to have inverse heredity, and that's really weird. Don't think about it too long, but we can talk about it over a beer. And lastly, differential fitness. Variations can do poorly or well with respect to how they are retained across time. So you would expect, given 1 through 4, that systems will tend to be more composed of those that do better than those that do poorly. This is just evolution in a nutshell. None of this should be surprising or controversial. This is what Darwin was saying, and the reason why when T.H. Huxley read The Origin of the Species, he hit himself over the head and said, oh my God, it was obvious, why didn't I think of it, is because it really just is this simple. You've got variations retained across time and doing better or worse. Guessing and checking over millions of years. That's it. Now, if you really, really want to be a maximum pedant, the way Lewontin was about a decade after that, 1978, you could say that doing poorly or well has to be due to the variations in order for it to be evolution by natural selection. But don't be a pedant. I do want to point out here that this recipe actually fits a variety of different ratios. You can have very little variation, and you would have relatively little evolution. You can have lots of heredity, in which case you'd have relatively little evolution. You could have identical fitness, in which case you'd have relatively little evolution. And we see this variation on life on Earth in different populations and in different traits. We all vary very little with respect to how many wings we have, for example. So you would expect, if we can tolerate these variations here on Earth, that we could tolerate evolution being quite different with respect to these features in other systems. Now, I've been quite simplistic and quite glib about evolution being this very basic logical argument. A lot of people have pointed out over the past century and a half that evolutionary theory can actually get more complex, that organisms are messy, that biochemical details matter, that population structures matter, that the particular chemistry and interactions matter, ecosystems and development matters. Yes, that's true. I am not going to challenge any of that. I think that all of those matter for certain things, but we are trying to explain when the exponendum, as philosophers of science say, is some particular variation or another, some particular mode or another. But you could actually, at the basic root, account for population change by having any number of other substrates represent, say, DNA, as long as it behaved in relatively similar ways. We can talk about that in Q&A. So the root logic is the same. And it's the same for most episodes of historical change. It's a historical proposition. Namely, the past matters more than the future, and the details matter for explaining particular changes and the rate of change. But the fact that general trends are the way they are, namely more fit organisms do better, can be explained by that logic and logic alone. And that might unify things as disparate as searching for life elsewhere, neuronal evolution, cultural evolution, or artificial life simulations on a computer. You can have that recipe that I gave, that logical argument, without having any creatures whatsoever. Now you might say, haha, checkmate, Carlos. A lot of people that have been pushing those have been wrong, in the sense that you disagree with cultural evolution being a kind of evolution. And I think that might be right. A lot of people that have been pushing for artificial life or cultural evolution or any other, quote, forms of evolution in different substrates have been overly ambitious with how strong the analogy is between biological evolution and the evolution of their particular subject of interest. The details matter, as I said. So maybe we should reserve the word evolution for biology the way it exists here on Earth, and instead talk about schmevolution. And that would be the general recipe thing that I'm talking about, this general trend of biology. Okay. Now, historically, philosophers have talked about biology with respect to this discussion between reductionism and anti-reductionism. And there's a lot of differences here, right? Reductionists don't think that biology has natural kinds. Anti-reductionists do. All biological explanations are enhanced by appealing to physics for reductionists, but not anti-reductionists. Biology is not an autonomous science by 1 and 2 for reductionists, but it is from 1 by anti-reductionists. What this means is reductionists have typically been the ones that think that, well, if chemistry and physics are the same elsewhere in the universe, we would expect biology to be the same elsewhere in the universe, and anti-reductionists have been relatively silent on this. So you can imagine reductionists thinking that evolutionary theory is a subset of physics, and anti-reductionists, when they point out that their law of evolution, principle of natural selection, is a discrete law in much the same way as many laws of physics, they'll say, no, 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 that's what makes biology autonomous. Well, I'm not sure I like this way of thinking about it. I don't really think natural kinds discussions have gotten us very far since Aristotle, and I don't know what it means to be autonomous. I'm not sure anything is truly autonomous. All sciences are interlinked. And furthermore, I've been arguing that evolutionary theory is just a bit of logic. And so you might say, okay, it's a bit of logic, but that has to be instantiated by objects. That's fine. But what I'm saying is it doesn't have to be instantiated by objects that behave in the same way that we think physics here on Earth behaves. You can imagine simulating a perfect simulation in a computer with plugging in different physics and getting recognizably evolutionary results. And people have done this. So that's my view. Here are ways you can challenge this view. You can say that that other kinds of biology can't be possible. You can say that this isn't the correct account of evolution. I'm not going to say any more about that. I disagree. But I will say that I do think that non-physical facts can be explanatory. So if logic in this sense can be explanatory, then it's similar to math. And think about this situation. You have 3 strawberries and you want to divide them among 2 people equally. You fail to do so, not because of any of the physics of strawberries. The only physics that matters is that strawberries are countable. It's a mathematical explanation why you failed. So you can have mathematical and logical explanations in reality, in the world. That evolution is manifested by life is a physical contingent facts, but the outcome of evolutionary setups is not. So those were my motivating questions, and this is my conclusion. Evolution is not derivable from physics. It's a basic bit of logic. Some principles from that point of evolution are more generalizable than the laws of the universe which realize them, which means that some of the accounts of evolution, culture, A-life, neural selection, etc., are actually accounts of evolution, or schmevolution, if you want to call it that, and can influence and affect the expectations that we would have for biological evolution. Thank you.